Hi everyone, my name is Shubhashish and welcome to the Art of Coding. This is my second video and today's topic is digital computer. So to begin with, any of a class of devices capable of solving problems by processing information in discrete form. It operates on data including magnitudes, letters and symbols that are expressed in binary code. That is, using only the two digits 0 and 1. By counting, comparing, and manipulating these digits or their combinations according to a set of instructions held in a memory, a digital computer can perform such tasks as to control industrial processes and regulate the operations of machines, analyze and organize vast amount of business data and simulate the behavior of dynamic systems, that is global weather patterns and chemical reactions in scientific research, different areas in education also. Now to start the second division, let's say the functional elements behind a digital computer. A typical digital computer system has four basic functional elements. First one, the input output equipment. Second, the main memory. Third, the control unit. And the fourth, the arithmetic and logical unit. Now, the control unit and the arithmetic logical unit are together known as the CPU or the central processing unit. Any of a number of devices is used to enter data and programming instructions into a computer and to gain access to the results of the processing operation. Common input devices include keyboards, optical scanners, whereas output devices include printers, monitors. The information received by a computer from its input unit is stored in the main memory, or if not, for intermediate use in an auxiliary storage device. The control unit selects and calls up instructions from the memory in appropriate sequence. The control unit actually acts as the supervisor for controlling the instruction flow. The control unit calls up one by one the instructions and regulates its flow from the main memory in appropriate sequence and relays the proper commands to the appropriate unit. It also synchronizes the varied operating speeds of the input and output devices to that of the arithmetic logic unit, or in short form known as the ALU, so as to ensure the proper movement of data through the entire computer system. Now, the ALU performs the arithmetic and logical algorithms selected to process the incoming data at extremely high speeds. Now, it actually depends on the type of processor that has been used. We have gone through different generation, right? So that is the processing capability. It depends on the processing capability. The ALU performs arithmetic and logical process by sorting out the incoming data at extremely high speeds, in many cases in nanoseconds, approximately billions of a second. The main memory or the control unit and the ALU together make up the central processing unit of most digital computer systems, while the input-output devices and auxiliary storage units constitute the peripheral equipment. Now, these are the basic steps of a digital computer. Now let's get to the development of computers, development of the digital computer. Blaise Pascal of France and Gottfried Wilhelm Leibniz of Germany invented mechanical digital calculating machines during the 17th century. The English inventor Charles Babbage, however, is generally credited with having conceived the first automatic digital computer. During the 1830s, Babbage devised his so-called analytical engine, a mechanical device designed to combine basic arithmetic operations with decisions based on its computations. Now, Babbage plans embodied most of the fundamental elements of modern digital computer. For example, they call the sequential control, that is, program control that included branching, looping, and both arithmetic and storage units, with automatic printout. Babbage's device, however, was never completed and was forgotten until his writing were rediscovered over a century later. Now, surprisingly, after a century later, it was discovered. Of great importance in the evolution of digital computer was the work of the English mathematician and logician George Boole. In various essays written during the mid-1800s, Mr. George Boole discussed the analogy between the symbols of algebra and those of logic as used to represent logical forms and syllogisms. His formalism, operating on only 0 and 1, became the basis of what is now called Boolean algebra, on which computer switching theory and procedures are grounded. John V. Atanasoff, an American mathematician and physicist, is credited with building the first electronic digital computer, which he constructed from 1939 to 1942 with the assistance of his graduate student Clifford A. Berry and Konrad Zuse, a German engineer acting in virtual isolation from developments elsewhere. Completed construction in 1941 of the first operational programmable controlled calculating machine known as the Z3. Yes, you heard me correctly, Z3. In 1944, however, Mr. Howard Aiken and a group of engineers at International Business Machines Corporation or IBM completed work on the Harvard Mark I, a machine whose data processing operations were controlled primarily by electric relays, that are switching devices. Since the development of the Harvard Mark I, the digital computer has evolved at a rapid pace. The succession of advances in computer equipment and hardware, principally in logical circuitry, is often divided into generations, with each generation comprising a group of machines that share a common technology. Nextly, in 1946, Mr. J. Pressburger and Mr. John W. Moseley, both of the University of Pennsylvania, constructed ENIAC. That's actually an acronym for Electronic Numerical Integrator. It's actually a digital machine and the first general purpose electronic computer. Its computing features were derived from Atanasoff's machine, which actually I have described in my first video. I'll put there's a link in the description below for your reference. Both computers actually included vacuum tubes instead of relays as their active logic elements, a feature that resulted in a significant increase in operating speed. The concept of a stored program computer was introduced in the mid-1940s, and the idea of storing instruction codes as well as data in an electrically alterable memory was implemented in EDVAC, that is Electronic Discrete Variable Integrator. The second computer generation began in the late 1950s when digital machines using transistors became commercially available. Although this type of semiconductor devices has been invented in 1948, more than 10 years of development work was needed to render it a variable alternative to vacuum tube. So 10 years was actually needed for the application or implementation of transistors. The migration from vacuum tubes to transistor took place 10 years. The small size of the transistor, its greater reliability, less power usage, less radiation of heat, and its low power consumption made it vastly superior to the tube. Its use in computer circuitry permitted the manufacture of digital systems that were considerably more efficient, smaller, and faster than their first generation ancestors. The late 1960s and 70s witnessed further dramatic advances in computer hardware. The first was fabrication of the integrated circuits, or in short form, the IC. A solid-state device containing hundreds of transistors, diodes, and resistors on a tiny silicon chip. This microcircuit was possible the production of mainframe, large-scale computers of higher operating speeds, capacity, and reliability at significantly lower cost. Another type of third generation computer that was developed as a result of microelectronics was the minicomputer. A machine appreciably smaller than the standard mainframe, but powerful enough to control the instruments of an entire scientific laboratory. The development of large-scale integration, or in short form the LSI, enabled hardware manufacturers to pack thousands of transistors and other related components on a single silicon chip about the size of a baby's fingernail. Such microcircuitry yielded two devices that revolutionized computer technology. The first of this was the microprocessor, which is an integrated circuit that contains all the arithmetic logic and control circuitry of a central processing unit. Its production resulted in the development of microcomputers, systems no longer or no larger than portable television sets, yet with substantial computing power. The other important device to emerge from LSI circuitry was the semiconductor memory. Consisting of only a few chips, this compact storage device is well suited for use in minicomputers and microcomputers. Moreover, it was found used in an increasing number of mainframes, particularly those designed for high-speed applications. Because of its first access speed and large storage capacity, such compact electronics led in the late 1970s to the development of the personal computer, or the PC, as we know nowadays. A digital computer small and inexpensive enough to be used by ordinary consumers. Now, at the beginning of the 1980s, integrated circuitry had advanced to the next level, known as the Very Large Scale Integration, or VLSI. This design and manufacturing technology greatly increased the circuit density of microprocessors. So like smaller field, however, you can punch in more power, more devices in a small surface area. Now, increasing the circuit density of microprocessor or memory and support chips, that is those served to interface microprocessors with input-output devices or I/O devices, right? By the 1900s, some VLSI circuits contained more than 3 million transistors on a silicon chip less than 0.3 square inch. That's approximately 2 square centimeter in area. The digital computers of the 1980s and 90s employing LSI and VLSI technologies are frequently referred to as fourth generation systems. Many of the microcomputers produced during the 1980s were equipped with a single chip on which circuits for processor, memory, and interface functions were integrated. Now, the use of personal computers grew through the 1980s. It increased rapidly. Not only 1980s, and it continued to 1990s also. The spread of the World Wide Web in the 1990s brought millions of users into the internet. The Worldwide Computer Network, and by 2015, about 3 billion people, that's half the world's population, had internet access. Computers became smaller and faster and were ubiquitous in the early 21st century in smartphones and later tablet computers. Now that ends my second video. I hope I might have missed out a lot of points. So if I have missed out a lot of points, please note it down and write it down in my comment section, because I'm a newcomer and I just want to go ahead and share my knowledge as correctly as possible. And if you like this video, please do not forget to subscribe to my channel, and if you like it, hit the like button and also the bell button to get notified for my further videos. I'll be uploading a lot of other videos. These are the beginning or the beginner videos: history of computers, history of digital computers. I will keep on updating and uploading videos like this one, from the basic level or the beginners level to the intermediate level and towards the advanced level. Hopefully you like this video, and thanks for watching.